What is geological formation? A geological formation is the most basic and fundamental block of lithostratigraphy. Such formations are assemblages of rock with similar characteristics. In geology, this term refers specially to geological strata, while in layman's language it is referred to informally as outcroppings of rock. The study and identification of these geological formations is a key part of geology. This allows geologists to do a variety of things, from carbon dating the landscape to identifying the availability of useful mineral deposits. Each formation consists of a certain number of strata, that is, rock layers, that contain facies, lithology, and various other features which are comparable and sometimes similar. Formations are not defined by the thickness of the strata that they are made of, which implies the fact that different formations can be very different from each other. Any formation is divided into members, and then these members are grouped together to be termed as groups. Formations allow geologists to study rocks and correlate strata across large distances between successive formations and outcrops. They help mark the geologic time from the very beginning, that is, from the birth of Earth. Geologic formations are best studied when viewed in cross-section. For example, if a hill is sliced into two parts, then the exposed part in each of the two will reveal the composition and layering sequence of the rock strata, which in turn will give the age of the formation. If a formation is identified by a geographer, then it is treated as a new discovery in case it isn't already registered, and the finder gets the honor of naming the geological formation. Stages of geological formation in India. The geology of the Indian Peninsula is a part of the Pangaea supercontinent, which was later roughly divided into three parts, and we shall discuss the geological formations of each part one after the other. These regions are rich in rock types, and that is why India is such a country whose geology comprises of all rock types that are possibly known today. Even the fossil proofs that are found in the region are remarkable, and it contains invertebrates, stromatolites, as well as plant and vertebrates fossil. The Deccan Trap. To start with, the Deccan Trap comprises of almost the whole area of Maharashtra and parts of Gujarat, Karnataka, Andhra Pradesh, as well as Madhya Pradesh to some range. It is presumed that the Deccan Trap was formed as a result of the subaerial volcanic actions that were related to the tectonic shift in this part of the earth during the Mesozoic period. This is one of the reasons why rocks of this area are generally of igneous category. During its passage towards the north after its separation from the rest of Gondwana, the Indian tectonic plate encountered a geologic hotspot which is known today as the Reunion hotspot. This phenomenon resulted in extensive melting below the Indian craton. The molten resources entered the shell of the craton in a massive flood of basalt occurrence, thus forming the Deccan Trap. It is also said that the reunion hotspot caused the partition of India and Madagascar. Vindhyan. The Vindhyan tableland is a geologic formation that consists within its creases the areas of Chhattisgarh, Bihar, Madhya Pradesh, Odisha, Maharashtra, West Bengal, Andhra Pradesh, Punjab, Himachal Pradesh, Uttaranchal, Rajasthan and Jammu and Kashmir. The earliest multicellular fossils of eukaryotes known to man were discovered in the Vindhyan basin some 1.6 to 1.7 billion years ago. It is vastly fertile with many tributaries of the Ganga and Yamuna flowing through its landmass. Gondwana. The build-up of Gondwana, or popularly known as Gondwana land, was a long drawn-out process. It was a supercontinent before which was created by numerous geological processes, causing its eventual union 550 to 500 million years ago, near the end of the Ediacaran era and into the commencement of the Cambrian era. These geological formations comprise of the East African orogeny, the Kunga orogeny, the Brasiliano orogeny, and lastly the Malagasy orogeny. The latter phases of the Gondwana accumulation overlapped with the unfolding of the Iapetus Ocean within western Gondwana and Laurentia. Through this gap, the Cambrian explosion happened. A major part in all these formations is also played by the plate tectonics of the Indian Peninsula. It is more active than the other plates of the world and has made some major contributions in the formation of the Himalayas. Everything from the world's tallest mountain ranges to the Vindhyan to the making of the Gondwana land was brought about by the chilling, hardening, twisting and fissuring of the plate tectonics beneath the earth. India happens to show a very diverse range of geologic formations due to the variety and uniqueness of the availability of rocks, minerals, temperature and ever-changing climates. Geological formations in Kerala. There are three main geological formations that are recognized in Kerala, and they are Archean, these are the oldest rocks, Varkali beds, these rock beds belong to the tertiary age, recent deposits, these rock beds belong to the quaternary age. These beds have north to south alignment. Crystalline rocks, Dharwar Formation. These formations occur only in the Malabar area and these are represented by mica, talc, garnetiferous ferruginous quartzite, schist, etc. And these are found exposed in the northwest of Gudalur and the southeast Wayanad. Champion gneiss. These are seen in southeast and south Wayanad. This type of gneiss has gold-bearing veins. The rocks are believed to be part of the post-peninsular age. Peninsular gneiss. This rock type is one of the most widespread and is found in Kerala. The important minerals that make up these rocks are feldspars, quartz, biotite and granite. In the Cochin area, the rocks form the most extensive beds. The categories present are hornblende and biotite gneiss. In the Thiruvananthapuram area, gneiss is made up of orthoclase, quartz, hornblende and mica and belongs to the Peninsula suite. Charnokite and leptinites are the most common gneisses in this area. Charnokite. A major part of the Western Ghats comprises up of charnokite. In the Travancore area, these rocks are well foliated and also show interfering relationships with the peninsular gneiss. These rocks are highly garnetiferous as compared to those charnokites in areas where garnet is absent like in North Kerala. Close-pet garnite. Archean interferences of post-charnokite age are seen in the Malabar region. The two intrusions of biotite granite found in Sultan's Bateri and Kalpetta hills have acute resemblance to the Don gneiss found in Hazaribagh. Precambrian system. Basic dikes. These rocks approach dolerite composition-wise and are fresh, fractured and myelinitized. These are found in the south of the Malabar area. Some basic dikes are free from olivine and are fine to medium grained found in the Cochin area. The coarser grained crystalline phases are signified by gabbros, whose exposures are found in the Cochin area. Residual laterites. A narrow zone of laterized rock exists to the west of crystalline rocks that constitute the eastern boundary of the state. The rocks exposed on the surface in this area are a kind of laterite which exhibit characteristics that is different from those laterites which cap the Varkala formations. The laterite conserves the structure of the mother rock and is less solid. The Varkali formation. This rock formation showcases the most noticeable sedimentary bed in Varkala, where they are best exposed near the seashore in the cliffs. These rocks consist of white and variegated clay, clayey sandstone, and carbonaceous clay which contain thin lenses of lignite. Recent deposits. These deposits are made up of silt and sand and are primarily developed in the northern parts. The mud banks of the coast of Alleppey, the lacustrine deposits made by the backwater tracts in Kerala, and the marine beach deposits along the entire seashore comes under this category. Mineral deposits in Kerala. Kerala is a very mineral-rich state and has a plethora of mineral deposits within its boundaries, like heavy mineral sands, namely zircon, sillimanite, monazite, ilmenite, rutile, along with other minerals like gold, bauxite, iron ore, graphite, china clay, tile, silica, brick clay, lignite, limeshell, limestone, granite, silica sand, limestone, gemstones, fire clay, etc. In spite of the availability of such a variety of minerals, 90% of the state's production is china clay and mineral sand. Mineral sand. The heavy mineral sand deposits in Kerala are made up of rutile, monazite, ilmenite, leucozine, sillimanite and zircon. The quality of this sand is world class and is found in the coastal tracts between Kayamkulam and Neendakara within the state. Gold. This precious metal occurs both primarily and also as a placer deposit. These occur mostly in the area of Wayanad and Nilambur. Most recently, its occurrences have also been found in the Attapadi valley of Palakkad. Iron ore. There are 5 deposits of the mineral, with one in Malappuram and the rest in Kozhikode district. Their capacity is 84 million tons of ore that contain 32 to 41% of iron. Bauxite. This mineral is found along the entire west coast of Kerala along with laterite. Some bauxite ores of economic importance are also found in South Kerala. China clay. This is of industrial importance and is found in 2 major sites. One of them is the stretch between Kundara and Thiruvananthapuram, known as the Southern China clay zone, and the other is the Northern China clay zone between Kannappuram and Cheruthalam. Ball clay. This mineral occurs in Alappuzha, Kollam, Thrissur, Ernakulam and Kannur districts. It works as a substitute for China clay. Fire clay. This mineral is found in the tertiary deposits of the coastal lands of the state, and its calculated reserves come up to be 11.50 million tons. But this mineral is yet to be put to use to its full potential. Brick clay and tile. These minerals are of low quality and burn red, but they fulfill the chief requisites of burning at low temperatures and easily moldable. These minerals support a widespread industry of 5,000 brick kilns and 400 tile factories in the state. Graphite. This mineral is found in its amorphous state. It is flaky and occurs in vein type around Vellanad, Changa, and valley parts of only Thiruvananthapuram district. Silica sand. Found in the Arur and Alappuzha districts of the state, the best deposits are found nearer to the coastal strips of Vembanad Lake. Lignite. This mineral was discovered very recently in the state and assumed importance soon after. It is being considered to replace firewood and coal. Crystalline limestone. The state is somewhat deficient in this mineral, and the few where it is found are in the Idukki and Palakkad districts. Kankar limestone. This type of limestone is found in the stretch between Chittor and Kolinjampara of Palakkad district. It is low graded and does not have much economic significance. Fossiliferous limestone. Found in various areas of the Kollam district. Lime shell. This mineral is not much available and occurs mostly in the backwaters, river mouths, lagoons and estuaries of coastal areas. Steatite. This is of importance to paper, textile, insecticide, etc. industries and is found in Kannur district. Magnetite. This mineral is found in little quantities in the Mulli Salayur districts and its total estimated reserve is 0.037 million tons. Precambrian geological and structural features of Kerala. Kerala is replete with traces of Precambrian features and structures, mostly dotted along its coastlines. The dike intrusions constitute of the prominent mafic igneous action of the Proterozoic era of the Precambrian time in the granulite regions of the southern parts of the Indian peninsula. These dikes are abundantly distributed over the gneissic cratonic region that is attached to the Kadapa basin. They extend into the extremes of the western Dharwar craton up until the coastal zones of Karnataka. Kondalites is another regional rock that is rooted in the history of petrological research in India pertaining to the Precambrian time. The use of this term remains tremendously linked to this region, though it spread gradually all over the world. More than 95% of the records on Kondalites in the International Database of MINLIP, which provides a bibliographic citation to a book, map, report or journal article, plus 1 to 30 lines of a keyword-rich text describing the content, are from India as well as Sri Lanka. Within India, Kondalites are found in areas that form a geographical arc of eastern and southern states like Andhra Pradesh, Kerala, Odisha and Tamil Nadu. The suite of these rocks includes quartz, sillimanite, garnet, graphite, garnet gneiss, quartzo-feldspathic and quartzite, which also hosts manganese deposits. The Angadipuram laterite is a national geological monument that is identified in Angadipuram town in Malappuram district of Kerala. The special significance is of the laterites that Dr. Francis Buchanan Hamilton had reported for the first time ever in 1807. It was termed as indurated clay and said it was ideally suited for building construction. These formations fall outside the common classification of rocks like the igneous, sedimentary or metamorphic rocks, but this is an absolutely sedimentary residual product. Laterites generally have a very pitted and porous exterior. The name laterite was coined by Buchanan from the Latin word lateritus, that means bricks. These exceptional formations are found over parent rock types of a variety of compositions like charnockite, anarthosite, leptinite and gabbro in Kerala. Varkala is an important place related to the geology of Kerala. It exposes the sedimentary rocks that belong to the Cenozoic age, which is also popularly known as the Varkali Formation in the geological literature. The Varkali and the Quilon formations show the sedimentary action that took place around the Kerala basin that existed in the Miocene era. The Quilon formations during the Miocene era is mostly made of limestones found near the Padapakara close to Kollam formations, which are similar to the Varkali formation of the Mayo-Pliocene era. These are made up of alternating beds of shales and sand that are exposed along the cliffs of Varkala. The Cenozoic formations are sedimentary in nature and are part of some of the unique formations of geologic features found along the coast of Kerala in the cliffs that are adjacent to the Arabian Sea. These formations are proof of the fact that Kerala plays an important role in the geological history of not only India but also the world in piecing together the information of geological importance pertaining to the Precambrian age. Types of rocks found in Precambrian system in Kerala. Over hundreds of millions of years, the geological formations of the earth has changed under the ever-changing conditions of temperature, pressure and other climatic characteristics. The Kerala coastline shows some extraordinary and abundant geological formations. One can easily find all kinds of rocks in the state, either in low or high quantities. Following are some of the rock types that are chiefly seen in the region. Igneous rocks. These rocks are formed when the molten magma from the volcanic activity solidifies after cooling. In case the magma cools rapidly, which happens only after a volcanic eruption, the rocks formed will contain crystals. However, on the contrary, larger crystals are formed if the cooling process is slow. Sedimentary rocks. These are the kinds of rocks that are found most abundantly here. They are formed by the accumulation of small particles or various other rocks that are a result of erosion and weathering of older rocks. These particles are then transported in streams to nearby seas and other large water bodies and thus start the formation of layers of sediments. It takes millions of years of compression to form such rocks. The younger rocks of this category are usually found on top of the older rocks in the Earth's surface. The sediments tell the story of their deposition process and evidences suggest that they were not continuously deposited. Even the close proximity of the sea cause ripple marks and affect the process and also the physical features of the rocks. Sedimentary rock layers are frequently folded, fractured or faulted, or tilted, and sometimes they are turned upside down. This is the kind of proof that shows that the crust of the earth has been subjected to enormous forces for too long, which has caused it to move and sometimes break completely or crack. Extensive activities of the crust of the earth have been known to cause mountain ranges to be formed over millions of years. These newer geological formations replace older mountain ranges that have been worn out by erosion and weathering. The sedimentary rocks of this area has been found to contain fossils of animals and plants that were alive during the age or time scale when these sediments were being laid down, and somehow due to the occurrence of natural calamities, their bodies got covered and over time trapped in these rocks. Metamorphic rocks. These rocks are formed when the other two types of rocks get forced deep within the earth and the subsequent high temperature and pressure of the crust cause them to transform into harder rocks characterized with bands of interlocking crystals. Although these rocks are formed deep within the surface of the earth, they can emerge at the surface from time to time due to the movements of the tectonic plates that form a very important part of the earth's crust. The availability of these rock types has attracted geologists from all over the world to study and conduct various surveys on these formations, which has not only boosted tourism but also the economy of the state. Conclusion. When it comes to geological formations, any geologist can have a field day in Kerala, India. The state not only has a rich history of geology dating back to the Precambrian era, but is also endowed with a vast plethora of precious metals and minerals, which has boosted various small-scale and large-scale industries. Not to mention the fact that the presence of these minerals has also supported many geological experiments, expeditions, and surveys conducted both by national and international organizations. Some of the minerals found in the region are exclusively produced here only. Most of these geological formations are a result of sedimentary deposits along the coastal areas of the state. However, a few metamorphic and igneous rocks are also found. Iron ore, gold, charnockite, laterites, various kinds of clay and various kinds of limestone are the most found minerals among other varieties. The availability of these minerals is not bound to one place alone, and their origins are scattered all over the various districts of Kerala. The entire area is well endowed and equally as well as abundantly blessed with the source of these resources, which have boosted the economy of the state by supporting the industries. Though some of these geological formations and mineral sources have been present there for millions of years, some are making their appearance very recently. A number of these minerals' potential have been identified and put to good use either as raw materials or as substitutes to them. However, there are still quite a few resources whose potential has not yet been identified, and studies are still carried to identify their uses.